Hello guys, Justin here, and today I'll be talking about currents or current. So let's just get right into it. Particles with opposite charges attract one another. We can view this by saying that the positive particles that are far away from the negative particle have a higher potential energy, just as in the case of gravitational potential energy. Particles with the same charge repel one another. We again can view this as a case of potential energy. Although gravitational fields affect all objects in the same way, electric fields have an opposite effect on positive particles than they do on negative particles. From a negative particle's point of view, the potential energy throughout space is flipped upside down as compared to a positive particle's point of view. Every charged particle contributes to shaping the electric potential energy at each point in space. The effect of each particle adds together. Suppose we have charged particles that are trapped inside a container. The charged particles will move to the edges of the container, causing the electric potential energy to be the same everywhere inside the container. This is a two-dimensional cross-section. The third dimension is not the third spatial dimension, but a representation of the electric potential energy. If a container with charged particles experiences an external electric field, the charged particles inside the container will react by again moving in such a way so as to cause the electric potential energy to be the same everywhere inside the container. In a metal conductor, the positively charged particles are always fixed on one spot and unable to move, but the negatively charged particles are free to wander around. When the metal conductor experiences an external electric field, one side of the metal will end up having more negative particles than positive particles and develop a net negative charge. The other side of the metal will end up having more positive particles than negative particles and develop a net positive charge. Therefore, the effect is the same as in the example of charged particles inside the container. The electric potential energy is the same everywhere in the metal. In an electric circuit, the negatively charged particles flow through metal wires. Metal wires that are directly connected to each other with metal connections are all the same electric potential. The difference between the electric potential energy of 2 points of a circuit is what we call the voltage. When a switch closes, it causes the two different parts of a circuit that it connects to be at the same potential energy. The number of charged particles that pass by each second is what we refer to as the current. When electricity was first discovered, it was not known uh, that it is the negatively charged particles that move through wires, and it was incorrectly assumed that it is the positive particles that are moving in the opposite direction. The convention for how we describe the electric current's direction was never updated, and we therefore still refer to this situation as if it's is the positive particles that are flowing in the opposite direction.